I'm SZandpour.
And I'm Malika Tor, and today I will be interviewing Sophia about the chemistry behind fireworks. To start, what role do metal salts play in fireworks?
Metal salts are chemical compounds that directly affect the color of fireworks. Without salts, fireworks would most likely produce yellow or white flashes. Different salts create different colors because every element has its own unique electron arrangement on the emission spectrum.
How do these salts actually create different colors?
These colors involve atomic structure, electron movement, and energy transitions.
What's step one?
Step 1 is excitement. The heat from combustion excites electrons inside the metal atoms. The electrons then absorb energy and jump to higher energy levels.
What's step two?
Step 2 is relaxation. The excited electrons quickly return to lower energy levels or their ground state. As they fall, they release energy as visible light.
Why does each salt produce a different color?
Every element has a unique arrangement of electrons. Because of this, each element releases a different wavelength of light when heated, which is called an emission spectrum.
Can you give some examples from the firework color spectrum?
Strontium salts release longer wavelengths of visible light, creating bright red fireworks. Sodium salts produce extremely intense yellow colors around 589 nanometers. Even small amounts can overpower other colors. Barium compounds emit medium short wavelengths that create vivid green explosions. Copper produces shorter, high-energy wavelengths that appear blue, and mixed salts are purple fireworks that are usually made by combining red-producing strontium salts with blue-producing copper salts.
I've heard blue fireworks are difficult to make. Why is that?
Blue is the hardest firework color to create because copper compounds are unstable at very high temperatures. If the explosion becomes too hot, the copper compounds break apart and the blue color fades.
What about purple fireworks?
Purple fireworks are usually made by combining red-producing strontium salts with blue-producing copper salts.
Why is temperature so important in fireworks?
Temperature is critical in determining how salts behave in the fireworks. If the temperature is too low, the salts will not excite enough electrons to produce bright colors. If the temperature is too high, some compounds decompose and lose their color.
Is this why blue fireworks are the hardest ones to create?
Yes, exactly.
How do chemists control this?
Chemists carefully balance fuel amount, oxidizers, salt concentration, and burn rate to create the brightest possible colors.
Is this chemistry used anywhere besides fireworks?
Yes, the same chemistry used in fireworks is also used in labs through flame tests.
How do flame tests work?
In a flame test, scientists heat metal salts in a flame. Each salt produces a unique color, and the color helps identify unknown elements.
What are some examples?
Sodium produces a yellow flame, copper produces a blue-green flame, and strontium produces a red flame.
And finally, do firework salts have environmental effects?
Yes, although firework salts create beautiful displays, they can also harm the environment.
What kind of problems can they cause?
Problems include metal particles being released into the air, smoke pollution, and toxic compounds from certain salts.
Can you give some examples?
Barium compounds can be toxic, and excess smoke contributes to air pollution.
Are scientists trying to improve fireworks?
Yes, scientists are developing green fireworks to reduce harmful emissions.
To conclude, what is the main idea behind firework colors?
The colors in fireworks are created by the chemistry of metal salts. Fireworks demonstrate how chemistry can transform simple salts into displays of light and color.
Thank you.
Thank you.